makers organized by the Indian Express Group. As many of you are aware, our past guests at Express Adda have been luminaries such as the Dalai Lama, economist Amartya Sen, Union Minister Nitin Gadkari, Olympic champion PV Sindhu, filmmaker Karan Johar, and writer Amitav Ghosh. This evening, I'd like to welcome Dr. Siddhartha Mukherjee to the Express Adda. As someone who's demystified and humanized public discourse on medicine and health with his empathetic writing, Dr. Siddhartha Mukherjee is familiar to many as the author of the Pulitzer Prize-winning The Emperor of All Maladies, a biography of cancer, and The Gene, an intimate history. But he's also an eminent oncologist whose recent initiative in Bangalore, Immunil Therapeutic Limited, in collaboration with biotech entrepreneur Kiran Mazumdar-Shaw, has been rolling out a significant clinical trial on the treatment of cancer called the CAR T-cell therapy. Already in use in several countries, this is aimed at significantly bringing down the cost of therapy for patients in India. New York-based Dr. Mukherjee has also recently published his third work, The Song of the Cell, an exploration of medicine and the new human, that takes readers through an exploration of the fundamental unit of life, the cell, and its integral role in medical science. We are hoping for a fascinating exchange of ideas in an interaction that will certainly offer a window into Dr. Mukherjee's undeniable gift for metaphor, besides, of course, the complex world of cell biology and a number of medical mysteries. Dr. Mukherjee will be in conversation today with Anant Goenka, Executive Director of the Express Group, and Devyani Onyal, National Features Editor, The Indian Express. The Adda today is presented by Rajiv Gandhi Cancer Institute and Research Center, co-presented by FOSTEMA and FRR Immigration, and in association with Devans. Our hospitality partner today is Le Meridian. Thank you. I'd like to welcome Dr. Mukherjee, Anant, and Devyani on stage, please.
Very warm welcome, ladies and gentlemen. When Raj Kamals, our chief editor, I think he's here today, when he asked me if, that Dr. Mukherjee is going to be here for an Adda, and he asked me if I would be interested in doing the conversation, my instinct was to say no. My instinct was to say no because, I think he's such a great speaker that I really felt I wanted to just sit back and listen and not have the, pressure of steering a conversation. But also because the two subjects I struggled at right through school, biology and chemistry. And so the word cell in the book itself was intimidating for me. But I'm very glad I resisted, I didn't go with my instinct. Because the book was a pleasure to read, absolute pleasure to read. It was so accessible. He made really complicated, sort of heavy science, very accessible, relatable, easy to read, easy to digest. I must say, I didn't expect that I'd finished reading the book before the Adda, but I did. It was really that nice and that lovely flowing text. The book is not only science. It's got culture, it's got history, it's got philosophy, it talks, it's got poetry, it's got patient stories, personal experiences, friends who have dealt with cancer, hero policymakers, regulators, philosophers like Aristotle. So it's got it all. It really is a wonderful book. I couldn't recommend it more. Siddharth, warm welcome to the Adda. Happy you're here.
Thank you very much. This feels a little bit like a firing squad. I'm on I'm on one end, and I might be shot by the two of you. But anyway, yes, I'm very happy to be here.
No, I think the one thing, obviously you're so eloquent and a great speaker, great writer, but in a sense, you're like a rock star researcher, rock star oncologist.
Why is it in a sense?
in all senses, in all senses. No, I think, you're this celebrity, you bring a sort of celebrity presence to what is a fairly dense, in a sense, boring subject. And it's interesting because if you look back 500-600 years and you ask a layman to name, 5, 6, the people that come to mind when you think about science, the best, the celebrity scientists, you get the same names. You get Newton, you'll get, Freud, you'll get Darwin, you'll get those same 5, 6, 7 names going back 500 years. But in the last 50 years, there's been a lot of advance in science, yet the celebrity names are, there's no that one rock star doesn't come up. Is that a fair statement to say that there aren't the rock stars in the past 5
I think there is that's a fair statement to make. We can actually talk about it quite in depth about what that statement means, but let's hold that thought. Yeah.
No. So unpack that for us. Why are these celebrity? I mean, why have scientists? Why are they not rock stars now like they used to be? Why are you such an anomaly as a scientist to be a rock star?
I can give you several answers to the question, and some of them are more complex than others. So let's start with the simple answer. The simple answer is that these days rock stars are rock stars, and no one else can displace them. So we are left clutching our test tubes. But that said, obviously I think the status of science has in some ways fallen in the eyes of people. That may be because of many reasons, but it has. Some of it is, science itself has dug itself into a hole. Its language has become inaccessible and complicated in a way that it wasn't before. Those would be, I would say, some first level answers to your question. There's a much more provocative answer to your question, which I'll talk a little bit about. Actually, I'm writing a piece about it right now for the New Yorker, so you'll see it in full form. There was a very provocative article in Nature magazine, which of course is the preeminent magazine of science, journal of science. And you don't need to read the article. Let me just summarize some of its the key finding behind it, because it actually leads to quite a deep conversation. The article tried to distinguish between two kinds of science and two kinds of medicine. One kind of, we've gotten right into it. I like that. But anyway, the authors are economists from Minnesota. The article tries to distinguish between two kinds of ideas in science. One which they call consolidative, and one which they call disruptive. So C and D, as they call it. Consolidative ideas, and this can be true for any discipline, but they happen to explore it in the sciences. Consolidative ideas take vast bodies of knowledge and condense them into something. And they give a couple of examples of taking vast bodies of knowledge and condensing them into something. There's a famous paper which describes the structure of the electron. I won't name the authors because you wouldn't recognize them anyway. But that would be an example of consolidative science. Disruptive science, disruptive technology, is quite the opposite. It starts off a field anew. Now you can apply, by the way, you can apply this metric or this CD idea to economics, social sciences, philosophy, architecture, art, etc., etc. But the nice thing about science is that you can actually quantify it. And the way that they decide to quantify it is actually fascinating. The way they decide to quantify it is by looking at scientific papers, articles in journals, and their hypothesis is that if science is truly disruptive, then the first mention of that discovery, so let's take Einstein's special or general theory of relativity. It is preceded by nothing. It arises, as we say, sui generis, Darwin's theory of evolution. It arises sui generis. No one has verbalized Darwin's theory. Newton's idea of gravitation is sui generis. It arises out of itself. There's no reference to it in the prior literature. So if a scientific article following the publication of theory of evolution, Watson and Crick's structure of DNA, and Franklin and also structure of DNA published simultaneously in Nature, Rosalind Franklin, Watson, Crick, they arise anew. And if you look at the index of publications that follow it, there is no precedent. In other words, they refer to Watson and Crick or Franklin's paper, but they don't refer to any paper before it because all the papers before it were wrong. So for instance, they don't refer to Linus Pauling's incorrect structure of DNA. Similarly, no one, when they refer or they talk about, say, Einstein's theory of relativity or Maxwell's equations, they don't talk about all the wrong theories that came before Maxwell or Einstein. They start with a reference to Einstein's theory of relativity, right? It seems to be an intuitive idea. If you think about, in the world of contemporary art, if you think about architecture, you can think about similar analogies. You see a building by Lou Kahn, and if you want to make a reference to it, not in a scientific journal, but in some way or the other, you're going to talk about some antecedents, but it arises sui generis. In contrast, consolidative science arises out of the consolidation of prior work. Now, what's nice about it is that you can actually, in the sciences, you can actually measure it. So you can take a single index paper, let's say Crick's and Watson's paper, and you can ask the question, whenever Watson and Crick's paper is referred to, how many times before that is another paper describing the structure of DNA referred to? And you can assign a number n to that. Everyone following me so far? Okay. So you can assign a number n to that. Or you can take another paper, let's say, as I said, a consolidative paper, and you can assign another number n to that. And you can thereby look through the period of history. And in this case, they used some advanced computational tools, some artificial intelligence, doesn't matter what they used. But they collated 25 million such papers. And the interesting finding, which I find fascinating, is that over time, contrary to our expectations, the number of truly disruptive papers in the sciences across all the sciences, including some of the quantitative social sciences, economics being one of them, has actually been decreasing rather than increasing. So we hear the word disruptive all the time. Everyone's disruptive. There's disruptive bottle openers these days. There's disruptive luggage. There's disruptive God knows what. Everyone's disruptive. It's as if we were in a classroom of attention deficit disorder children. But anyway, but the point is, what's interesting is that very consistently since the 1950s, the level of these truly disruptive papers, as quantified by these metrics that I just described to you, has actually been decreasing. And the question is why? And they advance a number of hypotheses. The hypothesis that I think is most interesting and most believable is that science is architecturally organized in a trunk and stem manner. In other words, it looks like a tree rather than what would we call a fireworks manner. So a firework has a center and lots of things point out of it. Trunk and branch architecture has a central stem and lots of branches come out of it. Science has a trunk and stem kind of quality about it, which is that truly disruptive science arises in a trunk-like quality and then moves into multiple branches. And the idea is that those trunks are quite rare, and in fact are decreasing.
But there are, I mean, there are more trees to be found, right? I mean,
I think there are more trees to be found, but they haven't been found they're becoming rarer to find.
In spite of the fact that there's never been so much money spent on research and science than ever in the history.
Fact that there has been so much money spent on research, et cetera, et cetera. So in some disciplines, we're waiting for the trunk. There's been a lot of consolidation, a lot of consolidative science, a lot of consolidative knowledge, but in some disciplines there has been not a lot of disruptive knowledge. Just to give you one contrast, there's a trunk that's growing amidst us right now,
right.
And that's the whole trunk of, I would say, machine learning and artificial intelligence.
Yeah.
And there will be, that's a truly disruptive phenomenon, and we can talk about it in greater detail. I've written about it, I've written about its effects on medicine, et cetera, et cetera. In cell biology, to be perfectly honest, that trunk goes back to the 1800s, the mid to late 1800s, when the trunk was established, and now we're in the sort of the branch.
The cell biology trunk was established in the 1800s.
The mid to late 1800s, yeah.
And the artificial intelligence is the new trunk that's being established now.
The sense is that it's a new trunk. It is a trunk that is going to be truly disruptive, and the branches, we're already starting to see, if you want to continue this metaphor, we're already starting to see the branches, but the trunk is being and has been established.
And with artificial intelligence specifically, there is a lot of, I feel there is more anxiety than there was with, I don't know, gravity or the theory or the trunk around relativity.
Well, there's quite a lot of anxiety around evolution, but that's okay.
Yeah. Around evolution.
Yes.
Yes.
When Darwin published his book, first of all, Darwin's book was a bestseller, which lots of people don't know. The printer had to run a print run 5 times because Darwin's book was such an earth shaker. But that's a separate point. But yes, you're going back to the anxieties around artificial intelligence.
And do you share anxieties around that? Or how do you feel about it?
So there are, as you know, there are 2 kinds of rather broad arenas. I'm not an expert in artificial intelligence, although I have created startups that use artificial intelligence. I use it to a limited capacity in my own work, not in a very deep capacity. Through collaborations, so I'm not an expert, but I engage with it quite a lot. I think there are 2 general phenomena here. One is so-called AI, and one is called general AI. So GAI, or general artificial intelligence. There's not a lot of anxiety about artificial intelligence per se. It's the general AI that causes a lot of anxiety, although I personally think that both should cause anxieties. So, for instance, the use of AI in surveillance, the surveillance of citizens, is obviously a cause of anxiety. Surveillance of political dissidents is a cause of anxiety. The use of AI in warfare, particularly the combination of robotics in AI in warfare, is a cause of, I think, absolutely a cause of anxiety for me, and I think legitimately for the general public. There are other aspects of AI which I think are very, very, not only just benign, but very useful. For instance, the use of AI in deciphering patterns in medicine. Who's going to get sick, in predicting genetics, in understanding biology, in understanding cell biology, et cetera, which are much less causes of anxiety.
Sorry, I'm going to disturb here for a minute. Guys, please at the back, if you come to listen to something, there's so much more and...
Thank you. Thank you. Please keep it down at the back there. Thank you. Thanks so much. Thank you for that intervention. I appreciate it. Thanks. Go ahead.
Sir, can I take you to your new book now? Is it on?
Yeah.
Can I take you to your new book now, The Song of the Cell? And the subtitle says Medicine and the New Human. So if you, it sounds a bit provocative. If you could just tell us what you mean by the new human, if you could just walk us through that.
Yeah, so, books are usually titled, my books at least, are usually titled quite late. Some people write the title of a book first and then write the book. I usually write the book first and then come back to the title. Your particular interest is the new human. Yeah. So I think that in many ways, including the creation of new organs, organoids, in the interface between cells and devices, including potentially devices that go into your brain, in the creation of transplants, transplanted cells, transplanted organs. We are creating humans that we haven't encountered before. We are creating people who, in some old technologies, would be called cyborgs, although they are not really cyborgs, they are cellborgs. They are interfaces between cellular therapies and human beings, and in so being are really sit at the borderlands of the limits of our current technology. So, so I think these are actually unlike sort of our sort of conception of new humans, which I jokingly call sort of Keanu Reeves in a black muumuu, you know, the kind of matrix-like quality that we imagine humans. In fact, there are people walking amongst us here who may have had a bone marrow transplant, in fact, and are living chimeras. So their bodies are their own bodies, but their blood is being made from someone else's body. There will be very soon people carrying artificial pancreases or pancreata. There will be people in whom we are stimulating neural circuitry to alleviate diseases such as depression. I mean, just to give you one example that you might think is very prosaic, when the first child was born in a petri dish, Louise Brown, born through IVF, there was no such human being in the world born in a petri dish and conceived in a petri dish. So I think we are creating these new humans, and they're much more real. They're amongst us. They're much more real than the science fictional new human. And I think they raise many, many questions and many anxieties, if you want to call it, many anxieties about who we are, what we do, and what our future looks like.
And actually, which brings me back to what I was asking earlier was, in a sense, these are such incredible innovations that have happened. And it's, you know, again, 15, 20 years, 30 years. Yet the disdain for science and the disdain even for doctors seems to be growing. And maybe COVID was a big catalyst for that. But why then? Why is there this?
Well, I think to some extent,
disdain's a strong word, but I don't know what word you would like to use.
I think to some extent, medicine has driven itself to the ground and not fully been able to convey its power and its tremendous impact on human history. I mean, I'll just give you the broadest example of this. I mean, it's in the book as well. I mean, in the 1850s or in the less than 100 years ago, the chances that when you had a child that you would die in childbirth were in certain areas on the order of 20–30%. Childbirth was a deadly event. The chances that you would die before you were 60 years old was, you know, on the order of 70–80%. Lifespans were 40, 50, 60 years. You would be lucky if you were 60 years old. In the last less than a century, even 50 odd years, we've seen an extension of lifespan well into the 80s in some countries. And we've seen the oldest humans well into their 110s, 115s, 120s, and so forth. So there's been a massive change, mostly affected, I think, by changes in it's not like medical intervention has caused all of this, mostly affected by larger changes in hygiene, sanitation, you know, social and behavioral health, but health nonetheless.
Yeah.
And I think medicine has come to represent not those, what I would call profoundly beneficial changes, but things that are divisive, things that are politically fraught. And there's been a lot of politics at work, in the sense of sort of the anti-science movement, the anti-vaxxer movement being one, one edge of that, the anti-science movement. So I think some of it is the fault of medicine itself, in being unable to convey its value to humans, and some of it has been the politicization and the divisiveness and the use of medicine as a scapegoat for political divisiveness, both in this country and in many countries around the world.
So also, do you think it's kind of paradoxical that this anti-science movement has also come at a time when, medical advancement has touched almost all lives and, saved so many lives? So do you see that as a kind of a...
Well, there's some paradox about it, but as I said, medicine and science has done a particularly bad job in conveying, demystifying, and really pushing it, making the public understand what it is about, what it's doing, what its purpose is, what the grand project is of medicine. They've done a very poor job of it. And I think and the result of it, as I said, is partly the fault of medicine and the medical sciences, and partly because of the political divisiveness. It's been used as a tool.
Is it also the commerce of it? I mean, there's a sense that
absolutely,
there's a sense that the motivation for science is becoming more and more commercial than it was. Would you agree with that?
To some extent, yes. I mean, the motivation of science has become commercial. There's certainly an element to that.
Which is not necessarily a bad thing, or is
well,
it?
So I was just going to say exactly that, which is that, the motivation of technology, digital technology, has been explicitly commercial.
Yeah.
And in fact, you could make a very strong argument that digital technology and social media certainly have had empowering roles in our society, but have had grotesquely divisive roles in our society. Even today, the main use of Facebook and Twitter seems to be to troll other people, et cetera, et cetera. But you don't see the same disdain for digital technology, which is number one, highly commercialized. Its sole purpose seems to be to make Mark Zuckerberg some extra money. Or Elon Musk, for that matter. Its divisiveness and its political divisiveness seems to be, if anything, just as deep, if not much worse, than medicine. But you don't see, people standing outside the office of Facebook with posters, or maybe you do, but you certainly don't see the public backlash. The anti-science or anti-medicine backlash that you see. Part of it also is because, we think of it, perhaps accurately, we think of medicine as something that is supposed to be benign. It's supposed to be not commercial. It's supposed to hold itself to higher ethical values and ethical standards. And that's absolutely fair. It is. It's a humanistic science. It's the most human of all sciences. Whereas maybe the digital world got off easy by starting to portray itself as a Godzilla and ending up as a Godzilla.
Yeah, but I mean, in your book, and I think in your books, I've not read all of them, but I certainly have watched enough interviews. There's a sense that I get where Big Pharma is kind of a villain in the book. I mean, if Big Pharma was a character, it'd be a villain. I mean, to what extent do you think, they've been extremely exploitative, somewhat exploitative? But, is Big Pharma become the villain globally that Big Oil used to be at one point?
I think Big Pharma has become the villain. I personally don't think it is the villain.
Okay.
I personally don't think. I think some Big Pharma can be a villain, just like I think Big Oil can be a villain, is a villain. In fact, to some extent, I think it is a greater villain. I think, big digital tech can be and is a villain. I mean, it really depends. We would not have the global outreach of vaccination, not just for COVID, but for all vaccines, had it not been for companies, just to name a few, Pfizer, Moderna, and AstraZeneca among them. You can't produce, a small company, a small startup cannot produce medicines for the world. You need the pharmaceutical. If I was to wave a magic wand and make the pharmaceutical industry disappear, I can guarantee it will be a loss for human beings.
Of course.
And so On the other hand, I think the flip side of that is, of course, that the pharmaceutical industry needs to take itself and its responsibilities pretty seriously, and find a middle ground, which it really hasn't. Now it has to some extent, but it hadn't. It was, highly resistive, highly resistant to change, highly resistant to the idea of social good, and finally, after multiple years of resistance, has finally come to a place where it's trying to recognize and starting to recognize the idea that it has to make some deep changes within itself. I don't think Big Pharma's, as I said, if I was to wave a magic wand and make Pfizer, AstraZeneca, and whatever, Bristol Myers Squibb disappear, I think the world would be poorer for it. But on the other hand, I also do think that the pharmaceutical universe needs to take its responsibilities quite seriously. I'll give you one last example of this. All of you must remember the role that Cipla, so I know Yusuf Hamid as a friend. I have the pleasure of knowing him as a friend. Remember the role Cipla played during the AIDS pandemic. At one point of time in most of Africa, virtually all the AIDS medicines were coming from Cipla until world trade agreements, really led by the pharmaceutical lobby, hand slapped and handcuffed Cipla, and essentially made the creation of antiretrovirals, monopolized the creation of antiretrovirals. Since then, there have been, since that moment, I think many of these companies have come to realize that there are greater social goods that they need to deliver on, and have started taking their role in all of this much more seriously, much more effectively, and much more responsibly.
Yeah, and do you think that just the amount of money and effort that goes into research is what they use to justify their profit margins, and they're extremely profitable. Most of these companies are extremely profitable. Most drugs that are extremely profitable. Is it the research that they use to justify? Is that how they keep their conscience going, or what?
It's a complex question. There have been multiple studies on this. There is, look, I make drugs, I make medicines.
I was going to come to that, because your arguments are not sounding like you'd be a very good businessman for your own company.
I'm not involved in the big pharma universe. I make drugs I make medicines in startups. So I'm not beholden or in any way.
But you are pharma. You're starting an organization. You'll be a pharma company in a sense, and you'll be creating.
That's right. But I'm not Pfizer. To take a step back, I think that making a medicine is extraordinarily difficult.
Yeah.
It is one of the most difficult and one of the most profound things that you can do, as saving a life is an incredible thing to do. Look around yourself. How many of you can say that you've saved a life? Anyone? I've saved a life.
Yeah.
So if you, I've saved more than one life, and I'm very proud of it. But I also take it very seriously. I think there's a lot of responsibility attached to that. It's not easy. It is extraordinarily hard work. Every single discovery that is life-saving has to be dug out of, as I say, cold, hard earth. So some of it absolutely is that there is a valley of death, very famously known as the Valley of Death, in which drugs fail. And for a long time, that's been used as the central justification as to why, when drugs succeed, they need to recoup the costs.
Yep.
of that failed research. I have become more and more of a skeptic of this idea.
Yep.
Mostly, as you very well know, if you look at the economics, if you studied with any great depth, you'll realize that most large pharmaceutical companies are surviving by gobbling up smaller, highly innovative startups. That's their modus operandi of survival. And in fact, a lot of research that's being done in Big Pharma, some of it is very good, a lot of it is not very good at all. But they survive by gobbling up a small startup. So I'm not the biggest believer in this idea. There may be some people in this audience who are, but that's not really my belief. My belief is that, that they gobble up startups. They do so relatively indiscriminately. Many of those startups themselves fail, and then they recoup the prices that they have to recoup by charging exorbitant amounts of the ones that succeed. Yeah. So they're essentially recapitulating the cycle of failure that's intrinsic to the development of new medicines. Just the last point here is that the way to get out of this cycle is not to crush innovation, but in fact is to encourage innovation such that instead of having that high rate of failure, you actually innovate to have a high rate of success. And there are many ways we can talk about how you can sort of tip the balance, as it were, so that you have a higher rate of success.
But, as a layman, one thought that I get is that most of the medicines that you see, all the work going into are all globalized solutions. The same drug cures fever anywhere in the world, or the same vaccine should work anywhere in the world. And I wonder, have we made the effort, has science made the effort of looking at local solutions, like maybe, and I'm completely, as I said, I'm challenged with chemistry, biology, anything medical, but old civilizations, whether it's Japan, China, Africa, India, there's so many things which we say is a local cure, a local solution to the cold, to the fever, to tummy bugs, to anything. Should we be focusing also on finding ways to harness that, suited to the climate, suited to the population? Or do we have to always find global solutions or globalized solutions?
I think the idea that there are global solutions has itself been quite challenged it has been challenged appropriately in science. So for instance, there's plenty of data suggesting, or plenty of work that's been done to figure out whether a drug that works in the United States works within racial populations, or I should say geographically distinct. The word race means different things to different people. I actually try to avoid it in conversations. But in ancestrally different populations in the United States. For instance, some antihypertensives, anti-blood pressure medicines don't work in African Americans while they might work in white Americans. That's been proven, tested with many drugs. And so there is an effort to figure out whether this sort of global solutions can be applicable locally or not. But to be totally honest, there are some diseases where the aberration of physiology is so deep and is so consistent. Take leukemia, for instance, or cancers in general. The aberration of physiology is so deep and so distinct that in fact the solution that is invented in Seattle may very, very well work in India or in some other place. So it really depends on what you're trying to solve. So in contrast, for instance, when you're looking at behavioral health or psychosocial determinants of health, drugs that work in the United States may very well not work in other contexts because the psychosocial determinants of health are very different in India. The behavioral health is very different in Southern Africa than it might be, compliance with a drug might be very different in, some parts of the world. Accessibility might be different in some parts of the world. So it really depends on what you're talking about. If it's cancer, if it's acute lymphoblastic leukemia, in Southern Africa is, I can tell you, pretty similar to acute lymphoblastic leukemia in San Francisco. Whereas, to take the opposite end of the spectrum, many studies done on this, the psychotic symptoms of depression are very different in different localities and different, situationally different, because people experience grief and mental illness very differently.
So could you also talk about your work in India? your company's work in India, the cancer therapy and the clinical
Yeah,
trials?
I have actually a bunch, but I'll talk a little bit about. I should say that I don't want to dilute the conversation towards Immunil in particular, because we have a separate session on the 21st, which is just coming up, where we'll focus really on the work that we're doing. In Immunil, we'll do a data release. But yes, I'll talk a little bit about it. We are the first company, or we are from work done in my laboratory and others, has found its way through the creation of T-cell therapies. So T-cell therapies are when you extract T-cells from a patient. T-cells are immune cells. You genetically engineer them in a hyper-sterile environment. I mean, this environment that we've created in Bangalore is totally up to FDA standards, or any standards, EMA standards, European standards, US standards, any standards. You take them into a hyper-sterile facility, genetically engineer them, and you to make them into anti-cancer fighting machines, their cells, grow them up to a large number, and then reinfuse them back into patients. And we've used them to cure patients. We are now, for some patients with deadly diseases like relapsed refractory leukemia. So their mortality without this therapy would be 100%. They would be dead. There are 8-year-old boys, 10-year-old girls living right now as we speak because they received infusions of this CAR T therapy. It's one of my proudest things that I've done. And I just noticed that one of our co-founders is in the audience. Kush, say hello. There's Kush. Kush, Kiran, and I co-founded this effort. This was not available to the Indian public, and is now in a phase 2B clinical trial.
That's wonderful.
We'll talk a lot.
Congratulations.
Yes,
but congratulations. I mean,
yeah,
this is something
it is
quite significant.
It is our proudest moment
It's quite
to
significant.
be able to do this.
And there has been progress, that right? I mean, recently I was just told some numbers came out last week. I think that the WHO was talking about a 30% drop in deaths caused by cancer in the US.
That's right. So yes,
which is interesting because the drug itself hasn't changed. The chemotherapy, right? I mean, the way.
No, it has changed. Well, some have changed. So, for instance, many have changed. Not all have changed, but some have changed. But many have changed, and I think that's very important to recognize that they've changed and what the changes are. I mean, in breast cancer, for instance, the changes have been extraordinary. So, in breast cancer, there's been a drop of about 1% in mortality every year for the last 20-odd years in the United States. Now, 1% sounds like a very small number, but if you take it across 25-odd years, that would be a 25% reduction in overall mortality from breast cancer. And that's because new drugs are in the armamentarium. There have been new ways of treating breast cancer. In some cases, in the case of leukemia, for instance, acute leukemia in kids, we're actually figuring out how to decrease the amount of chemotherapy rather than increase the amount of chemotherapy. I'll give you one last example, kind of an interesting example in multiple myeloma, actually interesting disease because we've had a lot of internal conversations. Multiple myeloma, there's a lot of multiple myeloma in India. We're actually making a T-cell therapy against multiple myeloma. It's going through the regulatory process right now. Hopefully we'll be able to bring CAR T cells against multiple myeloma very soon. In India, it'll be the first of its kind as well. Multiple myeloma, there's a lovely paper published about 6 or 7 years ago, which makes the argument that if you were to walk into a cancer clinic with multiple myeloma in 10 years ago, your chances of living 5 years out would be on the order of, let's say, 60%. In the last 10 years, your chances of living out 5 years from that is now 80 or 80-odd%. With acute lymphoblastic leukemia, ALL, lethal disease, your chances of mortality in 1946 was 100%. Your chances of mortality now in, let's say, about 5 years, it was now an 80% curable disease. And now with CAR T therapy, that last 20 or 15 odd percent, we're curing about 80% of that 15% that's left over. So we're really up in the high 80s, sort of low 90s number for a child. So yes, so absolutely there's been a big difference. Much of it has to do with cancer prevention as opposed to cancer treatment. So let's be clear about that. But in the case of breast cancer, it's not because of cancer prevention alone. It's a combination of prevention, treatment, and cures.
And reading the book, the one sense that I got was one of optimism. Am I right in catching that?
Yeah,
from that book?
This is an optimistic book. I mean, The Emperor of All Maladies was kind of, I would say, an optimistic, sobering book. The Gene, if you were to capture the mood, had a sense of anxiety about the future. This has, of course, a sense of anxiety too. We talked a little bit about some of the anxieties that I have about sort of the new humans, not only because we're changing who we are and how we imagine ourselves, but we also the economic implications, the political implications of that. But this is, in general, a much more optimistic book.
And so, but would you say we all should be feeling more optimistic, or do you think there's just so much happening aside from this book and this research, which actually, global warming, mental health, these kind of things? I mean, do you get a sense that we should be cautious, optimistic, more careful than we used to be earlier?
I think that answer is above my pay grade, because you're certainly invoking things that I'm anxious about, but actually don't know very much about aside from sort of, I imagine anyone else in this audience, global warming is not a topic that I know very much about aside from being anxious about it. Climate change, similarly, I do think that there are many, many things that we should be less optimistic and quite anxious about, but they lie outside my sort of area of expertise.
No, but does cell biology get impacted by climate change in a way where you feel it's impossible to study? I mean, because the markers are moving so fast now. Even the pace at which we live our lives, right? The cell is traveling faster and more distance than ever before. I mean, does that change how you can study the past to come to results for the present and future?
So, I mean, is your question, are you asking me if there's an intersection that I can think of between cell biology and climate change? Is that what
fundamentally,
yeah.
Not only climate change, but all the new stuff. I mean, things
well,
that are
so, I mean, the broadest thing I can say is that, I think cell biology or cells are the constitution of the human body is responsible for one of the most vital activities that we do, which is the maintenance of equilibrium. The jargon for that word is homeostasis, which means that, if I were to suddenly pick you up and throw you into the Antarctic, your body would have internal mechanisms by which it would regulate your temperature, for instance, back towards normal, and as much back towards normal as possible. So that phenomenon is called homeostasis. It's one of the hallmarks of life. I think, very broadly speaking, the larger climatic, geographic, and political movements that are occurring throughout the world are really challenging both social and individual homeostasis. And by that I mean it's very hard for people and societies and individuals to retain, for instance, mental homeostasis, psychological homeostasis, and to some extent physiological homeostasis when they're moving through extraordinary circumstances that may involve traveling, 5,000 miles on dirt roads in the middle of the summer. So in that sense, I think the larger events of today are impinging on our capacity as living systems to maintain social, mental, psychological, and personal homeostasis.
Right.
That would be one example of larger movements.
Now that we now that we were talking about optimism and anxieties, I just wanted to ask you about the pandemic. You have a chapter in your book on the pandemic that you say that, right when we thought we understood immune system so well, then biblically we tumbled. I think that's what you said. So, if you could talk a bit about that and about how the virus kind of interacted with cells. Why was it so severe in, say, some patients and seemingly fit?
Right. So the tumbling that happened, I think, is very important. I wrote several pieces for the New Yorker about this idea of tumbling. I think that there was a moment of time in which I think we, as a scientific community and as a biomedical community, thought that we understood vaccination, virology, and immunology among the deepest within the scientific realms. If you took all the systems, these were things that we thought we understood very well. And then all of a sudden, here comes a virus that really challenges very fundamental things that we know and don't know about how the immune system works, how the immune system. So for a long time, we had actually built pretty sophisticated models of the methodic way in which the immune system tackles a virus or a bacterium. And we thought we had covered the bases. If you would ask me to describe 10 years ago or 7 years ago the way the immune system tackles a virus or a bacterium, I could describe it pretty methodically, or I thought I could describe it pretty methodically. And then all of a sudden, SARS-CoV-2 has turned all of that upside down. We've suddenly realized that there are gaping holes in our knowledge about how the immune system works and how viruses can potentially contort the immune system such that it doesn't work the way that we thought it worked. I'll give you one example, and there are many. I'll give you one example. One example is the phenomenon of long COVID. So many people have talked about this. It's well known in the literature. But it's raised the question, which I suppose all of you should be thinking about, maybe there are long virus syndromes for many other viruses. And maybe we just have been ignoring them because we haven't looked. And it's because COVID was such a global pandemic that we've learned to understand the autoimmune consequences of COVID in the long run. But maybe there's a long influenza syndrome. Maybe there is a long Epstein-Barr virus syndrome. Maybe there's a long, whatever other virus that you might call it, whatever other bacterium you might be infected with. We don't know because we haven't been looking. And so all of a sudden, our assumptions about what the human body or how the human body deals with viral infections in the long run, in the 10-year run, 7-year run, et cetera, have all been, I think, quite severely challenged. I have a very mild version of long COVID myself. You may or may not, people who've heard me before can hear it in my voice. My voice has permanently changed since I had COVID. It's technically long COVID. But that's just my voice, and you hear it every day, and therefore you can get a sense of it. I have a sense of it. But there may be other parts of your body that are invisible for the most part to medicine, which may have changed permanently because of one infection or another infection. So that's, I think, the tumbling that has happened, and a re-examination. I wrote a piece for Cell magazine called "Before Virus, After Virus: A Reckoning." If anyone's interested in sort of these ideas, I think they're very, very provocative ideas, but they're all in that piece. So do read it, because we may be sort of just looking underneath the mat and finding all sorts of things that we hadn't discovered before. Your second question had to do with why do some people have very severe reactions to COVID? Well, we know quite a lot about it now. We didn't know about it before, and everything about this is surprising. Surprise number one is that it turns out that some people, apparently healthy, tends to happen more in men than in women, apparently healthy. So listen carefully and get this, have a pre-existing pre-existing autoimmune disease that has invisibly, because no one knew about it, invisibly affected their capacity to respond to viruses. They're living amongst us. We don't know about them. It's only when COVID strikes that all of a sudden that previously invisible incapacity to respond to the virus becomes visible. And those are people who are actually, so it's an autoimmune disease. Those are people who actually get very severely affected by COVID. Totally surprising results. No one ever had even heard about it before. So that's one explanation. Some people have genetic changes or mutations or variations in genes that have to do with the immune system. Totally invisible for the most part. No one knows about it. They go about their lives normally until COVID hits, and all of a sudden they become susceptible to severe COVID. Those are some examples. And we're discovering more and more about how some people, or why some people, have a greater susceptibility to COVID and to long COVID. I'll throw you another sort of surprising swinger. Previous Epstein-Barr virus infection is one of the major previous active Epstein-Barr virus infection, including previous mononucleosis, which is a consequence of Epstein-Barr virus infection, has a strong correlation with long COVID. Why? No one knows. But again, we're lifting up the mat and beginning to see things that we just really hadn't known about. Immunology, a subject that I've studied now for 30 odd years, and people have studied for 150 odd years, and all of a sudden are finding absolutely new things that we had no idea about before. Fascinating new ideas in immunology. The whole new branch of immunology, really.
All this COVID, we're talking COVID a lot, and one of the things that I believe was brought up at a recent talk that you did on the anti-vaxxers of America, why one of the theories put forth was that the idea of vaccination is actually an Eastern idea. It's not a Western idea. And that in itself creates a sort of sense of resistance to vaccinating in America. I thought it was a very fascinating thought. I wanted to
Amitabh brought it up. I was in conversation with Amitabh Ghosh in Kolkata 2 days ago or 3 days ago. Amitabh brought it up, and he's absolutely right. In fact, the book talks about it, about how the origin of vaccination. And Amitabh wondered aloud to what extent it was there's a xenophobic response about vaccination. I'm not sure I agree with that 100%. I think at least the anti-vaxxer movement in the United States seems to me to be driven by two kinds of strands, or three kinds of strands, I should say. There's a libertarian strand, which is a very prominent strand in the United States. So my body is my body, it's inviolable, you don't touch it, especially with weird things that I don't want it to be touched by. So there's that. There is now a kind of a new strand of anti-vaxxer or anti-vaxxerism that's arising, which has to do with exhaustion. People are just tired of being vaccinated. So we have to renew the messaging around vaccination, and we have to actually re-examine, for some people, what the strains are, what the pathogenicity or how pathogenic the strains are. I was talking to Berkha earlier on television. We really need to find out the data from China because we're really operating in a black box. Are there new strains arising? What is the pathogenicity of those strains? It's a big black box because what's happening there today, which we know a little bit about, is going to happen here tomorrow. And so we need really to put some strong pressure to release that data and to find out in reality, because it's all sort of rumor and conjecture, et cetera, et cetera. So there's that strand, sort of vaccine exhaustion. And then there's, of course, the anti-science in general strand. So there's a libertarian strand, the anti-science strand, and the exhaustion from vaccination. They've sort of collected together to create a kind of, I would say, a demonic trio of anti-vaxxers, some of whom I think can be convinced otherwise. So I think those who are exhausted, if truly the strain turned out to be quite pathogenic and there was a lot of pathogenicity, they could be converted back. I'm afraid the libertarian strand and the anti-science strand will only amplify.
I think we should do a couple more questions before we open to the audience. I know a lot of people here. It's packed house, not surprisingly, and there are lots of people who want to ask questions. But just one thought on, mental health. You've spoken a lot about mental health, and you've said that the Mukherjee family has, history of mental health and how you yourself have dealt with depression. And I'm reading this book, and I don't have the stomach for anything bloody, but there were some chapters that kind of got me, a little bit, whatever. It was so descriptively written that I kind of, had to take a second and pause and kind of just digest that. I really felt like I was at that moment. There was one particular incident with a guy from Boston. You've said that you never use the word bloodbath again because you literally had a bath in blood. And I just was wondering that what you do, it can be so emotionally challenging. It can be so difficult. You're telling patients that they've got 6 months, 6 years, whatever. You're telling, you're in the situation where you were covered with blood. Did you ever think about, the fact that this takes a particularly nasty toll on mental health, what you do?
I mean, the mental health situation in medicine is no hidden secret among physicians. There's burnout, depression, grief, grieving, et cetera, et cetera. Most of us have, over time, evolved mechanisms to deal with it. That doesn't mean that everyone deals with it successfully. I think situational grief is situational. I think it's no hidden secret that there is an enormous degree of psychological and psychiatric toll among physicians. But what can I say? If I had, I knew about it with my eyes open, and if I had chosen not to have done it, I would have become a plumber. Or maybe I'd have become a writer. Oh, I am a writer, sorry. But anyway, I think it's very important for me, and has been very important for me, to take the stigma of mental health away, and to describe it in, I hope, empathetic but also biological terms, because then it doesn't become, snap out of it, it's your fault, blaming the victim kind of situation. If you describe mental health, even if it arises situationally, even if it arises because of psychosocial reasons, if you ultimately describe it in neurological terms, in terms of the brain, in terms of the body, you can't slap your neurons into behaving. So you suddenly begin to realize that there are perhaps deeper biological reasons that something is happening. And I do think that takes some of the, slap yourself out of it stigma that surrounds mental health, not only in this country, but everywhere around the world.
And what do you find the distinction between, in India and abroad? I mean, do you feel like there is more mental health than we know in India? Is there any distinction you would make, looking at this field here in India and outside?
Well, I think classically there was a lot of underdiagnosis. There's a lot of somatization, or when mental health is underdiagnosed, you tend to people. Again, has been classically noted, it's converted into physical health, or the lack of physical health. Chronic trauma, chronic stress can lead to many alterations in human physical health, and so I think there was a lot of stigma, a lot of underdiagnosis. In fact, when we were growing up, there weren't even words in our lexicon to describe some of the most common mental health aberrations. Now there are the words, the lexicon is growing. We understand the behavioral and the psychosocial elements of it in a much deeper way. I think the conversation is much more open about it, but I still think, and I think most people would agree, that there's a lot of underdiagnosis.
Yeah. And there's fundamental school of thought which says that the more you go away from nature, the more you're kind of fighting a losing battle, fundamentally. So whether it's mental health or any sort of stream of science, do you agree that we've kind of gone too far away from nature in our daily lives, in our way of living, in the lives that we sort of aspire to live?
I'm not sure what exactly that means. I mean, tobacco is a natural product. It's horribly nasty for your health. So there are many natural things that are quite bad for you. Tigers, snakes. It's
no,
not
but like, I mean, what I mean by that is, I don't know, sleeping when the sun sets. So what things like that we keep talking about.
Well, I think, if you're talking about sort of existential ennui, that's affecting the entirety of our species. It's not clear that sleeping under sunset will solve the existential ennui that's affecting all of us. So I don't think that's going to be the answer. I think that there's a profound sense of existential ennui. I think it's caused by many things: social dislocation, the rather now increasingly grotesque economic disparities. Ivan Illich, the sociologist, has many times remarked that relative poverty can have as much trauma as absolute poverty.
Yeah.
I believe that to some extent. I mean, there is a certain line beneath which it changes. So I think there are many reasons for what I call existential ennui. That seems to be the malaise that's affecting us. But I'm afraid I don't think that sleeping under sunsets or sleeping under sunrises is going to be
before. I mean, like with the sunset, sleep with whatever I meant, not under the sunset.
Yes.
I think we should get to the audience. Can I get a sense from show of hands? Okay, wow, we got a lovely one.
So I just have one policy, about questions, which is, and I'm happy to have you ask questions. I generally like to have questions be male, female, other, male, female, and other as we go along, because men tend to hog the mics constantly. And I'm saying this because actually people have studied this. I'm quite data-driven, so I would highly appreciate it if we could.
No, I love that. Yeah, let's do that.
All right.
So let's start with female, please. Yes.
The immunotherapy that you spoke about that you're developing in Bangalore, is that going to substantially be different in pricing to what is presently available in India today, which is being administered?
Well, there isn't anything in India today, so there's no comparison. The therapies that we're trying to administer will be substantially cheaper than they are in the United States and in Europe. Now, that said, there's a fundamental cost of goods associated with making these therapies. They are extremely difficult to make. They are not easy to create. You require a facility the size of, I would say, this entire basement to be in a hypersterile environment to create them. So you can only drive the price down to a certain point of time before it becomes impossible to produce. So we are trying every single piece of Indian ingenuity, including engineering talent, et cetera, to bring it down as much as possible. But for this to be sustainable, even in the short run, there's a fundamental price barrier. I'm not even talking about there's a fundamental cost barrier that we have to deal with. And as I said, we are using every inch of Indian ingenuity already to try to bring the cost of goods down to as bare bones as possible and survive still as a startup.
Because it is so prohibitively
Yeah, I mean, so
expensive.
I'll just give you the sense of what the numbers are in the United States, which would be impossible. So all in, a single bag of CAR-Ts produced by, let's say, Novartis or a company, all in is priced at $450,000. That's all in for the bag. Add to that the treatment and the hospitalization, and add to that the pre-treatment. So in other words, these are for relapsed refractory patients. So they've already gone through their cycles of chemotherapy, et cetera, et cetera. So you're really looking at a figure on the, let's say, $800,000 range. And as a friend of mine once said, half of infinity is still infinity. So half of $800,000 won't cut it. And so the answer is, whatever we get to, it's not going to be half of that. It has to be much more substantial than that. But that said, there is a bottom price, as it were, that the cost of goods itself carries. And we can't go below that price unless we have, some form of innovating our way out of that cost of goods.
Dr. Sudhir Raval? Yeah, please.
I have two questions from you. One is late 80s and early 2000, there was a lot of hype, a lot of news about cloning and gene therapy. And at one point of time, we thought the gene therapy probably will cure the cancer. And now we don't hear anything. Same thing in cloning, that probably it will end up with the organ cloning, maybe genetic engineering pig. That also, I don't know what is the status. Probably you can highlight or repeat it.
Yeah, so so the T-cell therapies that we and others are developing are gene therapies. So there's no ifs, ands, or buts about that, and they are curative. They are being used. They are now licensed as medicines, and so generally speaking, there's a 10-year lag between the hype around a topic and the reality, and this sort of fits right in there. 10 years ago, we were talking about gene therapy. These days, we're deploying it. We're using it in humans. There are at least 6 or 7, maybe 8 drugs that are FDA approved that are gene therapy drugs. In fact, the last multiple drugs that have been approved are gene therapy drugs, including gene therapies for blinding eye diseases, gene therapies for other diseases, all of which were recently approved by the FDA and are slowly making their way to other countries. These include curative therapies for sickle cell anemia, beta thalassemia, some rare diseases, all of which have now started responding to gene therapies where there were no medicines before. So that's one. And the second idea that you talked about is cloning. Now, cloning in the traditional sense of making animal copies is certainly not the way that things have gone. But I should say the scientific community has now worked quite deeply on making animal models, including pigs, which can be xenotransplanted into humans. That work is going along quite well, actually, ever since the development of new tools, including CRISPR. Has been going along quite well and probably will be in patients within the next year or so. So we're there.
Like in gene therapy, what happened at that time in 2000, we thought there is oncogene and we will probably have a drug for that.
That's right. So
and we'll end up in many genes.
Not turned out to be the case, but it's turned out to be the case that you can genetically engineer the immune system to attack cancers. It's a completely different story.
So this is another question is just a bit different, like not from science. What do you think that cell has? Does it have a soul, or it is just a chemical reaction for consciousness?
I think neither. I think the cell has neither a soul nor is it a chemical reaction for consciousness. It's a least living unit of life.
Somebody identifies other, can I?
Or another woman, I don't know. You don't have to be.
Yeah, because they're right there. The lady in the back, standing there, behind, please. Please introduce yourself and then ask the question.
Hi, Dr. Siddhartha. This is a pleasure to meet you. My name is Samara Mahindra, and we have launched an integrative oncology company in India called Carum. So we propagate a lot of non-clinical therapies for oncology, like nutrition, physical therapy, psychological intervention. You speak a lot about nutrition. Can we speak a little bit more about that, especially in a country where it's still looked as something that is a good to have, but we still need to build a lot of evidence supporting how nutrition and these therapies can actually help treatment and patient outcomes?
Yeah, I mean, you know, my own intersection with nutrition is, I would say, much less integrative than perhaps what you're setting out to do. We've been focused for a while on identifying particular vulnerabilities of cancer cells and identifying how to use diet really as a drug. And usually we've been doing this with diets in combination with drugs. So it's a very different modality. We try to identify, we've now actually published several papers in which we've identified vulnerabilities of cancer cells that depend on particular micronutrients, such as particular amino acids, particular hormones, including insulin, etc. So our intersection is very different. It is very reductive, very non-holistic, and it is now undergoing clinical trials. So we're in the middle of clinical trials for that. In the arena of cancer prevention, I think there's a lot that needs to be still done in terms of nutrition. I'm really not an expert on that. All I can tell you is that there is a well-established and strong link between obesity and cancer. India is a country, and several other countries are growing increasingly obese, and we absolutely know that that an integrative approach to curbing obesity, which combines both medical and non-medical approaches, is helpful. And so in the realm of cancer prevention, I think there's it's not going to be micronutrient deprivation. It's going to be a much more holistic approach towards, or a more integrated approach towards cancer prevention. So I think that's an arena where it's going to be very likely to have a much larger impact than the very reductive things that we do.
Mr. Kala, Dr.
Yeah,
Kala.
Sunil Gala. Here's the one question taken from this nutrition and cancer. That recently one has been reading a lot about nutrition as a prevention and cure for cancer, which is plant-based food and intermittent fasting and autophagy and things like that. So are they effective? And if yes, then what can be done to disseminate this knowledge to bottom of pyramid? Because this is a low-cost solution.
Yeah, so they're very different. Intermittent fasting is very different from plant-based foods. You can become quite obese eating plant-based foods. I can guarantee that. But intermittent fasting is a different story. There have been, actually I reviewed, and there have been several strong preclinical papers about the role of intermittent fasting and the insulin axis in animal models on cancer. At least two, I would say, pretty well-regarded papers on this. These have still been entirely in animal models, and the record for translating from an animal model into humans is highly checkered. So I would caution everyone, if you hold the healthy skepticism that we just talked about, that most drugs that work in animals don't work in humans, then you should be equally skeptical that intermittent fasting that works in animals may or may not work in humans. We'll have to find out. There are multiple trials in progress about it, but as I said, in general, people who believe in sort of this integrative, holistic approach to medicine, my general plea to them is that if you're going to hold one standard, you have to hold the same standard be consistent with standards. which is that if you're going to hold the standards that drugs that work in animals don't tend to work in humans, you should also hold the standard that intermediate fasting that tends to work in animals may or may not work in humans. We just have to see what the data shows when the first clinical trials come out. There's no reason to believe one and not believe the other.
I'll take a female next, please, back there, the red. And then we'll come to the first row here.
Thank you. Hi, Siddhartha. It was very interesting to listen to you. As someone who
Introduce
is not a
yourself, please,
scientist, yeah,
Siddhartha.
I'm Leher. And my question to you is as a mother, you know, we live in one of the most polluted cities in the world, where the general AQI, irrespective of whether it's winter or summer, is above 100. In fact, it's 250 something now, and the bans on construction, etc., have already been lifted. I read somewhere, you know, WHO had done some research saying that children born in this environment, this kind of pollution, and children whose lungs develop and their organs develop in this kind of pollution have permanent lung damage and damage to various organs. And it's also been proven that, you know, as per research that I read, that, you know, children born here and pregnant mothers who give birth in pollution like this also suffer in the long run, as you know, the life expectancy goes down by about a year and a half, ranging between a year and a half to, you know, whatever. So is there also a connection that is possible between living in an environment like this and, you know, diseases such as cancer later on in life?
Yeah, so
it's something that really concerns a lot.
That's right. So it's been explored, but it's not been explored at the depth that we need to explore it, and that's partly because there isn't a longitudinal. The biggest problem is that there isn't a good longitudinal database of cancer in many of the most polluted areas of the world. We need one. We need an incidence. We need mortality data, incidence data, et cetera, Now, some of this data exists for asthma, for instance, among other diseases. For respiratory diseases, there's a lot of data now that suggests that there's an increase in respiratory diseases. There is good data for growth retardation and stunting in the context of sanitation and pollution. There isn't very good data on cancer. So it's an unfortunate gap or a hole in the data, partly because we don't have longitudinal cancer surveys to tell us this. It is being rectified. So at the highest levels, multilateral organizations have now launched, as the demographics of the world change, and as chronic diseases, as opposed to acute infectious diseases, become more and more prominent in countries like India, these questions have to be taken with more and more seriously. I mean, the funny story was, for the longest time, you know, the classification was of diseases across the world was contagious versus non-contagious diseases. That's like saying that the animal kingdom is cows and non-cows, which is absurd, because in fact, now the so-called non-contagious diseases are taking over. I heard the other day a statistic that more people in Tanzania will die of hypertension than they'll die of you know, the typical contagious diseases that we associate with lower income countries. So as the demographics of illness change, these longitudinal surveys become more and more important, and in fact there's a large multilateral effort to get these longitudinal surveys. COVID really put I would say a sideswipe to that for a while, because of the excess mortality associated with COVID, but we are coming back now to, as we come back to a little bit more of an equilibrium, we have to re-explore the idea of what the longitudinal surveys show. I wouldn't be, to be honest, I wouldn't be surprised if some cancers there was a link, but it's just too early to tell.
Lots of more questions. I'll take a few more, but a quick intervention of my own.
Yeah.
Research in India, that we have, you know, some of the best doctors in the world.
Yeah.
But somehow research medical researchers, we don't get a lot coming out of India. Why is there a way we can solve that?
Well, number one is incentivize it, make it easier to do, make it easier to practice, incentivize it at every level, have government support for it, have federal support for it, and make it there are carrot and stick ways of doing this. A tiny country like the United Kingdom produces some of the world's most valuable research, not only epidemiological, but also basic science and so forth. But it really does so because, it's had a long ecosystem. And you don't build these ecosystems overnight. You need a real concerted effort to build these ecosystems. In some ways, I think, ironically, the techno hubs of India, Bangalore being one of them, which is why we started in Bangalore being one of them, has really enabled a certain kind of ecosystem of research. The fact that the Indian Institute of Science is there, the Institute of Genetics is there, et cetera, but it really requires, the US spends, on the order of $50 billion on the NIH, and another $50-odd billion if you combine the Department of Defense and other, various other organizations, so a total of about $100 billion. And even so, everyone in the United States thinks that both fundamental and basic and clinical research is severely underfunded. I don't know what the numbers are for India. I think it's the order of $1 or $2 or $3 billion odd dollars equivalent. So for a country of its size, we are way under the curve of even being close to what the United States, for instance, funds, or the United Kingdom, a much smaller country, funds.
Yeah. Yes, please. Introduce yourself and then take one back.
Yeah, I'm Anup Mishra. A couple of disclosures before I ask my question. Number one, I'm an allopathic doctor, not a proponent of indigenous system of medicine. And number two, I'm not an oncologist. My question is that there are some good points in indigenous system medicine. One of them, of course, in general is yoga. But the other one, which has been known quite some time, was treatment of leukemias. And one of the elements which emerged from that was arsenic. And arsenic trioxide is an established treatment for acute promyelocytic leukemia. And surprisingly, people don't give credence to indigenous system medicine for that, because it's known for 20, 25 years, at least. When I was in All India Institute of Medical Sciences, several patients of AML went to Ayurvedic people first and then came to us. So why can't we do more research there? And there's huge number of possibilities there. So what are your thoughts about it?
Well, if you're talking about, AML is my sort of subject. So acute promyelocytic leukemia, for which arsenic trioxide works, is a tiny, tiny, tiny fraction of all leukemias. So to make a generalization about all leukemias, in fact, arsenic trioxide has absolutely no effect. In fact, is poisonous to the human body and all these other leukemias, and is generally poisonous for other, and has no effect or can be poisonous for other cancers if given at the wrong dose. So it just happens to be that that particular relatively rare variant of leukemia happens to have a genetic reason that it's sensitive to arsenic trioxide. That's not to deny the fact that there are lots and lots of potential discoveries to be made. I'll come back to the same question of standards, which is that the standards of proof for a medicine to work or not work have been established since the 1800s, and they're quite simple. They tend to, whether you call them, whether there's a progression, as it were, from preclinical studies to clinical studies to phase 1, phase 2, and phase 3 studies. My general plea to anyone who believes in any form of medicine, whatever it might be, is that the standards be the same, that we don't compromise on the standards. As long as we do that, I think we can explore lots and lots of different kinds of medicine and lots of different kinds of interventions. But we can't shift the standards around. You can't say, oh gosh, you'll never find an effect because the way you're looking at it is the wrong way, because we have our own way of looking at these medical effects. Whenever that's happened, it's caused a slippery slope in the conversation. Now that said, this is not to, I often say that virtually all of our pharmacopoeia in medicine, including in oncology, is derived originally from plants. It's only lately that we've been starting to make medicines that are not plant-based or plant-derived. That said, there was an institute that the NIH created, whose task it was to discover medicines along the same standards, using phase 1, phase 2, and phase 3 data from the natural world. So from what you might call, I don't like to use this word, but from the non-allopathic world. The total number of drugs, so they existed as an institute and they've now been absorbed into another institute, but the total number of drugs that came out of that for the treatment, I'm not talking about prevention, prevention is a different story. For the treatment of cancer, the total number of drugs that came out of the effort was 0. They may have been looking in the wrong place, they may have been doing the wrong kind of studies, but they used the standards that are used to create or make any drugs. So with all those caveats, the total number of drugs that came out of that effort for treatment of diseases was a big 0. There have been efforts to reinvigorate such an institute, but given that track record, it's going to be hard to do that in the United States. If someone's willing to fund such an effort outside, I think it would be welcome. But thus far, the effort in the United States came up with nothing.
We'll take 2 more questions, please. There's a lady at the back there I saw. Yes, please. Go ahead. Can you get a mic to her, please? And if you can introduce yourself, and I think we can try to keep them as short as possible.
Yeah, it'll be very short. I'm Poonam Dabas. I'm basically a journalist, and my question is on biowarfare. With so much of research and studies being done into this field, there are always rogue elements. And there are lots of theories which are floating, and I would like you to comment on that the COVID itself was a kind of a biowarfare. We haven't got much information either from the WHO or from China, which are both closed doors. So would you like to comment on that?
Yeah, I'm being asked to comment on COVID endlessly. To be honest, as I said, I'm not a COVID expert. I do follow the literature. When I go into some particular aspect of COVID, I really think deeply about it. I look up material deeply on it. If you ask me sort of what I know in terms of what I can defend based on what I know in terms of the scientific literature, I think the idea that it was a pure act of biowarfare seems to be unlikely to me based on what I know from science. I think the jury is out there still, and there's a vigorous debate going on in the United States and elsewhere that it was an accidental lab leak. I think so biowarfare is a different story. The jury is out there about an accidental lab leak. The WHO, as you very well know as a journalist, sent an initial team to Wuhan to investigate whether this was a potential lab leak. That team concluded that it was not a lab leak, that there wasn't enough evidence, and the matter seemed to be closed until the report of that team was finally released and found to be quite lacking. They had not done large parts of what seemed to be relatively obvious tracking and tracing, et cetera, et cetera. The big red flag for the biological community, at least, was that there happens to be one institute of bat research in the entire country of advanced battery research. It happens to be in the same city that COVID seems to have originated from. And so that was the origin of the lab leak theory. There have been genetic sequences that have been advanced. And if someone's interested, I'm not the expert on this, I would follow both sides of this debate. Alina Chan, a biological researcher at the Broad Institute, was among the first to really raise the question of whether this was a lab leak or not. Her work has been, has been contradicted by the work of others, very respected virologists, who've said that lab leak theory does not hold. This is a back and forth that's going on. I should say that I don't know Alina personally, but I have been following all her work and all the initial publications that emerged from that work. The sad story about all of this is that she has been the target of really horrible trolling on social media, and has been really targeted by social and non-social media for bringing up even bringing up the question. So I don't know the answer. I don't claim to know the answer. I do know that this whole question is being revisited very actively. There probably is on the order of 1 to 2 papers on one side of the debate and on the other side of the debate every month, published in highly respected journals that make the argument that this was a lab leak or this was not a lab leak. I think that no one knows for sure, and I don't know whether it remains politically feasible or not to re-explore the question. I'm going to say one last comment, which is the only thing that one gains from this debate. There are 2 things that one gains from this debate. One thing is that if there's even a suspicion of a lab leak, it just means that we need to have better systems of laboratory protection, and that's a given. That's a given in the sense that that's a win-win situation. It's not like someone's going to say, let's relax the rules around, dumping things down the sink. If anything, it means that we have to be more vigilant. That's one. That's a good that comes out of it. And secondly, there has been a lot of political pressure on China to be more transparent in its in whatever it does in its research. I think that's the second good thing that's come out of that. So whether it's a lab leak theory or not, time will determine. I can't tell because it seems to me that there's sort of one push and one pull in either direction every month, and it seems to be there seems to be ultimately no direct line of evidence, conclusive evidence in either direction.
But short answer, is the WHO equipped and to do this, to actually, obviously the political pressure aside, and if they get the access, can they actually implement these standards that you think, are they qualified and good enough to do it?
So the WHO could have been good enough to do it. I did read the original report. I thought it was lacking. Unfortunately, you get only one chance at settling the issue, and that chance was somewhat squandered. So that's where the matter will have to rest, at least for now, until there is a global pressure to reopen all the boxes and reopen all the files, much of which may have been destroyed.
Yeah. The question here, please, in the front, please. And then we'll go on to...
Hi, I'm Amrish Mittal. I'm an endocrinologist in Delhi. As endocrinologists, we've seen a huge change in disease profile. I've been practicing almost 40 years, and there's a huge change in the way diabetes used to present. You spoke about obesity. The disease profile has completely changed in many ways, much more Western disease profile than what we were taught as Indian disease profile. The same changes have taken place somewhat in the cancer profile in India. When we were students, then colon cancer didn't happen in India. Prostate cancer was not common in India. We know all those things have changed. And some of them, in our field, we always say, it's your lifestyle that's doing it. You're eating the wrong stuff. You're not exercising enough. And there are other factors like maybe pollution, as the lady mentioned. Do you have a sense, or is it just that we are living longer?
Well, so I think it's multifactorial. I've talked about this extensively in multiple interviews, and I talked about it in the first book as well. So I think certainly extension in lifespan has something to do with it, but I think it's not the only thing that has to do with it. So as you can tell, it's not just the a change in the number of cancers. It is a change in the as you might call it, the Venn diagram, or the I shouldn't say the Venn diagram, sorry, the pie chart of the kind of cancers, the age at which the cancers are presenting, and so forth. In India, we're seeing, for instance, I'll just give you one example, a lot of young patients with multiple myeloma, which is, and relatively, people who've relatively experienced in the field have raised the question whether there is really a different variant and maybe related to some endemic viral infection. And it's a theory that it's plausible. It's a plausible theory because that's a cancer which has to do with B cells, which are the first responders to microbes and so forth. So there's a changing epidemiology in India. Lung cancer, we know the obvious culprit there is, of course, changes in smoking habits, et cetera, et cetera. Lung cancer was a virtually unheard of disease, 50, 60 years ago, 70 years ago. Lung cancer in women was absolutely unheard of in the 1900s. And then there was an epidemic in the United States as women started smoking or were enticed to smoke. Colorectal cancer is another great example where I think there's a strong link, when Dennis Burkitt went to Africa. Again, some of this is anecdotal evidence. He saw no evidence whatsoever of colorectal cancer. And there, the suspicion is it's related to diet. Endometrial cancer has become, again, the epidemiology of endometrial cancer has changed, ovarian cancer, both related to obesity. So the biggest driver, clearly, is the increase in lifespan. But if you look with a deeper microscope, as it were, a demographic microscope, there are broader changes that are very clearly evident that have to do with changes in various things.
Okay, I think we're running out of time. Lots more questions here, but I'm sorry, I'll have to cut short. And because we've taken a lot of time of Dr. Mukherjee, I'd like to end with a rapid fire, Siddharth.
Okay. I told you it was a firing squad.
By the time the bullet reaches you, you'll have come up with some T cell that'll block it. So I'm sure.
Right.
It's going to be a little bit, from left field, but still, bear with me. You said in the book you don't believe in rebirth, but do you believe in destiny?
You mean predetermined destiny?
Yes.
No.
Do you believe that there's life on other planets?
Yes.
Your favorite scientist, alive or dead?
Albert Einstein.
Why?
General theory of relativity.
Okay, now I'm going to try to get you to play a game, okay? It's called use, reduce, stop.
Okay.
So I'm not asking for scientific explanation, logic, none of that. I'm just, imagine you're talking to your dearest loved one, somebody who, you just, family, whoever. And I'm going to tell you a substance, and would you tell me to use it, reduce using it, or stop using it?
Okay.
Okay? And this is in the context of cancer, because we don't know
Okay.
what really is carcinogenic now, what isn't. So, easy one, tobacco, you'd say stop. Stop. Microwaves.
Use.
Plastic packaged drinking water.
Don't know.
Plastic packaged food, any plastic packaged food.
Don't know.
But if your loved one is eating from a plastic packaged food, you would not comment.
So, the answer is I don't know. I can tell you what I do in my own practice.
Yes.
Which is that I use, but I don't heat.
You don't heat, okay. Dairy.
Use.
Artificial food colors.
Don't use.
Artificial sweeteners.
Don't use, but not for cancer reasons. I don't use it for reasons that have to do with endocrinology more than anything else.
5G.
5G as in cell phones?
Yes.
Use.
Use, okay. Cell phone towers, cell phones.
Use,
okay.
use.
Wi-Fi routers.
Use.
Hair dyes.
Stop.
That had a lot of reaction. I got the age profile right now from that response. Silver cling foil.
Silver what?
Silver cling foil.
Tin foil, you mean?
Tin foil is
use.
Use. Okay. Well, this has been great. So thank you so much. Thank you for your time. Thank you for
All right,
being
you're
here.
welcome.
This is really awesome.
Thank you, Dr. Mukherjee, for such an enriching conversation. Thank you, Anant and Devyani, for steering it so well. I'd like to invite Mr. Rakesh Chopra, Chairman of Rajiv Gandhi Cancer Institute and Research Center, to present a little bouquet of flowers to Dr. Mukherjee. I'd now like to invite Mr. Raj Kamals, Chief Editor, The Indian Express, to present a memento from the Express Group. Do we have Raj here? It's a portrait by our illustrator, Shubhajit Day. I'd like to also mention our partners here. Today's Adda was presented by Rajiv Gandhi Cancer Institute and Research Center. It was co-presented by FOSTEMA and FRR Immigration and in association with Divans. I'd also like to thank our hospitality partner, The Meridian. Please join us for some cocktails. Thank you.